Last year I talked about the U.S. Energy Information Authority, or I talked about the amount of money that needs to be spent in the next 40 years to respond to electric utility demand. They said there's about $62 trillion has to be spent in the next 40 years to meet the new demand. And not only that, we're seeing renewables coming on stream, wind and solar, which are highly variable. We're seeing enormous growing demand for electricity, particularly driven by just population growth and the emergence of a third world. But also the web itself is consuming enormous amounts of energy. Michael Goodchild from the National Science Foundation in the U.S. said at a speech a few months ago that a single Google search, if you look at the entire lifetime of a single Google search, consumes enough energy to boil a cup of water. That's astonishing when you think about the demand that that's going to create for energy. The smart grid is going to be the biggest change in energy delivery in the past 100 years. Our transmission towers and networks are running on analog relays, workers going out and switching up and down things on transformers with switching the bus bar manually. All of that's going to be automated, far more electronics. In fact, Obama's committed $40 billion this year for smart grid. What is a smart grid? Well, this is very interesting. I've been doing a lot of work with our users on this in the last couple of years, and it's really taking a massive information system connected to smart meters. It's a meter in every house that constantly meters the power consumption and communicates that back to a central facility. I believe BC Hydro just recently committed $1 billion to putting smart meters in every home in BC. Ontario is just about complete. And around the world, these smart meters are going in. They're going to allow things like time of day metering. When demand is low and the power plant can't be shut down like a nuclear plant, they need to know they'll cut the price of power. Hopefully that will get people who have their electric cars, as we see down on the bottom here, charging them in the middle of the night. And then those cars will actually be sitting on the grid. They'll be sitting on this information system. The VP of Operations for the Calgary Electric Utility asked me, he said, do you think GIS can handle taking a reading on every conductor every 5 seconds? I want voltage, current, and temperature of the conductor. And I want to record them every 5 seconds and store them in a database and analyze them. In fact, he told me that that's a project that Google is working on right now, is how do you actually take this massive amount of data about the network and turn it into a geographic data which can be used to better manage that network. So I think it's fairly clear to all of us here that in the future the Geoweb is going to become very pervasive, a part of everything we do. It's enabled by many rapidly evolving technologies. Every time I go to a major conference and drop around to a GPS booth, I'm amazed at the increase in accuracy from cheaper and cheaper devices. I was in a booth a couple weeks ago from a company from Montreal that sells post-processing software. And they were able to take some relatively inexpensive Garmin devices, $150, $200 devices, that happened to support some of the protocols for post-processing, and they were getting well under sub-meter accuracy with post-processing with a cheap device. So it's fairly clear to us in the industry that the handheld devices that we carry around with us, a phone that we get for $100 with a GPS receiver in it, will be well under sub-meter, in fact probably sub-foot in the next few years. GIS technology continues to grow. Cloud computing. I got an email from some business, some investment firm here not too long ago that said, what are the 2 words that scared Bill Gates so badly he retired? And when you read down further, the 2 words were cloud computing. It's gone from nowhere on the top of IT concerns studied by the Gartner Group in 1 year to the top of their list. Wireless continues to grow. We're seeing this controversy in Canada right now where Nortel has gone bankrupt and they're proposing to sell their wireless wireless business to Ericsson, and it's causing a national political discussion. Mobile devices are getting cheaper and cheaper. The iPhone is a phenomenon that's just taking the world by storm. Earth observation. I was at a briefing by the Director General of Remote Sensing in Canada here a few weeks ago, and he was telling me about the satellite called Tandem. Excuse me. Tandem is a German satellite. How many people have heard of Tandem in the room? Anybody heard of Tandem? I got one person's heard of Tandem. 2 people, several. So Tandem is a satellite that's actually 2 satellites. So the Germans launched one a couple years ago, and it's a radar satellite, and they're launching a second one, which will actually be in a helical orbit, a pattern around it, so that the 2 satellites will be a couple hundred meters apart and form an ultra-long baseline for interferometry. And the result is the entire world will be mapped by radar on 12-meter grid with 2-meter accurate elevation. And they're going to be receiving all this in Inuvik. So Inuvik is the only place in the world, in Canada, or it's the only place in the world that has electricity and roads to it that can build a receiving station that can see all Earth observation satellites in polar orbits for all of their orbits, and has a window long enough to transmit all their data down to the station, check it, and have enough time in the orbit to retransmit it. So there's going to be staggering amounts of data coming from these satellites. In fact, the reason they needed a road is the networks aren't fast enough to move all the data out fast enough from anywhere. So they're going to be shipping it out on discs on trucks. So this is going to create a staggering amount of additional information in the next little while. Services-oriented architectures are emerging, not just inside organizations, but across the internet. And developer tools are evolving extremely fast. I believe I heard just last week that Microsoft is going to have a free version of Visual Studio shortly that can be bundled with other software. And those tools the development is extremely rapid. Dave Sonnen at a conference in Quebec City a few months ago talked about things that have become incredibly cheap, unbelievably cheap. Geographic location is one of them. Getting location is one of them. Another one is development. And because development is so cheap, failing has become cheap. You can try anything. And if you fail, too bad. Start again. But policies and governance have to change as well. We're seeing some big changes around the world, particularly in Canada here over the last 7 or 8 years, of free data and free access to that data. We're seeing privacy policies that articulate what can and cannot be done. We're seeing SDIs continue to be funded. In Canada, the GeoConnections program is Canada's SDI. And we're seeing public-private partnerships emerge to manage data with governments and the private sector working together. And in particular, the work of you as a team, you as a community, will drive this development of the Geoweb. One thing that the Geoweb does very effectively is pulls together data from the GIS infrastructure that's been evolving over the last almost 50 years. In fact, Roger Tomlinson told me last week that he got his first working prototype of the Canadian Geographic Information System going, was able to overlay 5 polygons on 5 other polygons in 1960, and then got it funded in 1963, $40 million in 1963. So since then, we've been building this infrastructure, which is largely inaccessible. And when emergencies happen or people are interested in community awareness, what's happening in my community around me, or in homeland security, or in the military has always used maps on a wall with pins in them. Utilities have always had some kind of large board in front of them that is connected to their SCADA system, their supervisory control and data acquisition. Now they're starting to get, so using the Geoweb, that they can pull this together and see it live.